Hey, what is up, guys? Welcome to the 16th day of Integral a Day. Today we have another trigonometric integral here for us all to practice that, as I've been saying in the past two videos, I've been finding it really interesting to master all these different identities and knowing how to manipulate them. Manipulate the function in order to make it, a lot easier to. Things playing up. Damn it! Stop doing this. Technical difficulties right here. Alright, so yeah, we need to manipulate this function here to integrate it now. So the way we can do this is, as I learned today, I use this new trig identity that pretty much says 1 plus 10, and I always just got to have this in the back of my head. Now we're going to write it in terms of x because I find that's usually how people write it. So you put a secant. So that's it here, and we're going to use that in order to simplify this. And the thing I really like about trigonometric identities when integrating them is you have to sort of see ahead and like look at it and think, oh, now how can I pull this apart to make it easier and use the techniques I already know to integrate this. So as we can see, we can probably we can use substitution if we actually pull this apart and make it secant squared x. So yeah, 10 squared q secant, it's just a power rule here, because this here can be split up like so. Yeah, oh, no, like so. And now what we can do is transform this into 1 plus 10 squared x, or 10 squared q. So 10 squared q, then times that by 1 plus 10 squared q. Yeah. Now we still have the secant squared q, but what we can do is use our u substitution here to get rid of this. As like we learned previously, we use u substitution to get rid of the variables that we don't want, so that we're just integrating it in terms of like one term, or like, so pretty much we just want tans. So if we make u equal tan x or tan q, then du here will now equal, well, the derivative of tan q was secant squared q, dot dx, and now we can, oh, my bad, dq. And now if we rearrange this, we can make it so that dq is equal to, And this is what will get rid of our secant squared x here, because what happens is we got dq is equal to du over secant squared q here. And now we can rewrite this as the integral of, well, we write it in terms of u now, so u squared times by 1 plus u squared, and then that's times by, well, we're still timesing it by c, and squared q here, dot du, because we're going to substitute this in for the dq. I'm going to put this in place, and it's all on over secant squared q, which allows us to actually eliminate this. Let's go a bit of a different color. I'm just going to put a line down here, so I can continue my working over here, so that now we can say that integral of u squared 1 plus u squared dot du, and we can just, you know, simplify this a bit further so it's a bit easier for us by timesing them in like this. So u squared plus u4 dot du will equal, now we can integrate this fairly easily, so it'll give us a nice value. So we get, we're not writing that integral side anymore, we're just, it's just the reverse power rule, which is in the first 3 videos of this channel. U 5 over 5 dot, nope, plus c. So we're done integrating now. So that sort of gets cancelled out. And now we just substitute u back in for tan q, and we should have our answer. So tan cubed q over, actually I'm going to write it as, so 1 over 3. I'll just bring the fraction out front. 1 over 5 tan 5q plus c. And there we have it. So let's just check this on Symbolab quickly. So dot dq, tan, I do not know what's happening to my typing today. Wow. Should do the trick. And we get the same answer. Awesome. So, congratulations and good work for those of you who actually got this right, and good job to everyone who may have got a different answer. If you got a more simplified answer, please let me know how this could be better in the comments. If you're a bit confused on anything, let me know in the comments what you're confused on. Just let me know how you went, and I'll see you here tomorrow for day 17 of Integral a Day.